This is Møller Nielsen from Java Code Geeks, and I'm going to teach you how to write clean, efficient code using structured query language and databases. If you're new to databases, and if you don't know what all of these abbreviations actually stands for, then this video is something for you. Now, complementary to this video, there will be related articles in the description below. Please take the time to like, subscribe, and hit that notification bell so you know when we have more stuff coming up. Now, without any further ado, let's get started. At javacodegeeks.com, we have a lot of cool articles, and one of them is this article about which interview questions and also answers to those questions that you could actually expect to be met with when you want to land that job within the IT branch. So I'm going to go through the basic questions in this article, and then of course I would also recommend that you actually read the advanced questions afterwards, and that you also read some of the other articles that we have, especially about Docker, because we're going to use Docker to start up a database locally on our own machine. I'm using VS Code, which is free to use and free to download. And I've installed the Docker plugin, and I've also installed the Postgres SQL plugin, and that gives us these syntax highlighting, as you can see right here. Get the right color for the right stuff. And the first thing that we need is that we need a database before we start. Then we need a database that we can actually play around with and try stuff with ourselves, because the best way to learn is actually to do stuff. And the way we actually can find this Docker image is to go to hub.docker.com. And if you prefer MySQL, then you're also more than welcome to download the MySQL version. I like Postgres because Postgres is punishing us a little bit more regarding the syntax. If the syntax is not exact, if we try to insert a different type into a table than the expected type, then we will be then Postgres will complain a bit earlier than MySQL. MySQL will many times try to think about what could then be put inside the table instead. So that is why I've chosen Postgres. But if you prefer Postgres, then find the Postgres Docker image, and the way you do that is, of course, you just go to hub.docker.com, and then you actually just type in the database that you prefer. In this situation right here, Postgres, and then you scroll down to the middle, and then you can actually find a Docker Compose recipe that you can use out of the box. There's no volume mapping, as you can see right here. This means that as soon as you are done with your Docker container, then all of your data, all of the things you actually did, those will disappear. If you want those to be persisted, then of course you also need Docker volume mapping. If you don't know anything about Docker, then watch our Docker video first before you continue. But I've already taken this part right here, and I've copied it into my folder that I have right here, dockercompose.yaml, which is right here. And I have a database service right here, where I have this image named Postgres, and this is the official Postgres image. And then we have an environment variable. This is the password that I'm going to use, and the password in this situation is just Mike, and the user is Postgres. Then we have something that is very, very cool for people that want to learn about SQL, that want to try the structured query language and try to understand and get a hang of it. That is this adminer application right here. This actually enables us to go to localhost port 8080, because that is what we are mapping this adminer to. And we can actually get access to this database that we have right here. It is pretty awesome, but let us start it up and let us see then, what it looks like. Docker Compose up. It is so easy with Docker Compose. Now we actually, of course, we always need to check the output. There's no errors in the output, and we can see right here that we have this database, and we also have the administration. Started up. We can see that right here. We have the inside the Docker container. It uses port 432, which is a default Postgres port. That is what our admin application is going to connect to. Let us just see that it works, and then we will go back to the questions that we could actually get at a job interview. So I can now go to localhost port 8080, and I can type in Postgres as username, and the password is Mike. And then we say login. So now I'm actually inside. Now I'm actually inside the client module for this Postgres database right here. I can create a new database by pressing this create database right here. Create database, and then we can name this Galaxy. This. So now I've actually created a database named Galaxy. In here I can then create tables, etc. But right now we actually don't know what a table is because we have not come to that question yet. So now let us go to the questions and take them one at a time. First of all, what does SQL stand for? It stands for Structured Query Language, so it's actually a language that we can use to communicate to the database engine, and the database engine will then carry out the commands that we send to it. It means that we can create a database. We can also create tables. We can create rows inside the tables, etc., etc. We can also drop tables. Like the drop table is the same as a deleter table. We can also delete rows. But we can do all of our commands with Structured Query Language SQL. Now, what is RDBMS? RDBMS is Relational Database Management System. So that is just a relational database that will carry structured data. And there are some keywords here that you need to remember. And of course, you need to know what SQL is, RDBMS, and you also need to know that Postgres and MySQL are relational databases. That means that you can actually create relations between tables. Then we have question 3 right here. What are tables in SQL? And it is actually just a collection of rows. So it is a way that we can organize our rows in, and we can also define what kind of types do we want inside this database collection. What are data types in SQL? The data types, that is the fields that we want inside the table, that they can have different types. Maybe we want a name that should be the text type. Then maybe we want an age that could be an integer, a whole number, and we could also maybe have a weight that could be then a decimal instead. So data types are a definition and a description of what kind of data do we have inside the table, which fields can each row contain. How do we define a record in SQL? We define it as a row, so that means that it actually has a set of columns, or fields as I also call them, and they have different types as we just talked about. And we're going to see some hands-on examples in just after this next question comes. What are different types of queries in SQL? We have something named DDL. That is if you are using create, alter, drop queries. That means that if creating a new table, then it will actually be in a DDL query, and that stands for Data Definition Language Query. This will define the structure of and the data type in the table. Then we have DML, which is Data Manipulation Language. This is every time we insert something into a table, every time we update a table and update some of the rows inside the table, every time we select something from the table, or every time we delete rows from the table, then those will be classified as Data Manipulation Language Query. You can actually just see your SQL contains these keywords right here, one of these keywords, then it would be DML, Data Manipulation Language. If it contains one of these keywords right here, then it will be a Data Definition Language instead. Then we have DCL, a Data Control Language Query, and that is used for administrative purposes, like partitioning database or creating new users or granting roles to that user, etc. So that means that if your query does not contain any of these keywords up here, then it would usually be a data control language. At least if you are if you're doing something with users or partitions, etc., roles, etc., then DCL. Okay, so now let us get some hands-on examples. Because first of all, how do we insert? First of all, how do we create? How do we create a new table? And the syntax is actually like this. You have create table. That's a fixed part. Then you need to name your table something. Captains right here. And then you need to give a round bracket like this, and then you need to give all of the fields right here. That means that we want, in this situation right here, we want a table named captains. We want an ID as the first column. Then we want and then we say that the ID is actually a primary key, and it cannot be null. We want this field to be filled out always. Then we have a name right here, and that has the type, the data type text there. Again, they cannot be null. We have not null. It's a constraint, right? Then we have the age, which is an integer, a whole number, and then that can also not be null. And we have experience. That could be some kind of captain experience. How good is the captain to fly to fly an airplane or a spaceship or whatever we think that this situation is about. So this is the syntax. If you want to alter a captain, a table, we can also do that by using the alter syntax right here. Alter table, captains, and then we can drop a column. Want to drop a field. Want to do that. In the beginning, if you're not that, if you don't feel that, if you don't feel comfortable with the language to begin with, then the admin client actually will help us a lot. Because right now we are inside the Galaxy database. I'll just go back to Galaxy right here, and then I can press create table. So we will actually get some help illustration interface right here. Then I can say that my table should be named captains. I want an ID. I want a column which is ID right here. I want it to be auto incremented. This means that this will be a primary key when I do it like this. Then I want a name for each of my captains, and that should be text. Here you can actually see all of the types right here. And then we have text right here. You can also set constraint to the text length. How many characters should we be able to use? In our situation, we will not put any constraint name right there. Then we have age, which is a whole number. And again, we will just say that it could be whatever the user actually types in right here. And then we had the experience, which is right here. That could be an experience level from 0 to 10, for instance, just a number to show how good the captain actually is. And then I press save right here. The table has been created. If I made any error or mistake inside the data types, if I gave a data type that did not exist, then this bar right here would not be green and it would be red instead, and you would get error message. Then we can actually see which SQL command was actually executed. Which SQL was executed by pressing this one right here. And this is actually how I got the file content inside my VS Code projects before. Then you can copy it, and then you can actually place it inside your project. So you have this SQL for later on, and this means that when I'm restarting, I restart my container, then I can easily create these tables right. It is very normal to take your definition, your SQLs and your definitions of all of the tables, and then placing them in the same project as your code. You just have another folder that will be database SQLs or something. This makes it easy for developers to create their own local database, and then they can actually just have the same structure as you want in your production database, for instance. So now our table has been created. Let us just press right here. Here now we have one table named captains right here. If I press my captains table right here, then we can see there are actually no data inside it because I get this no rows. So now let us go back to the questions. This was just to get some hands-on. Sometimes it's nice to get a feeling of what is actually happening by actually executing and some real stuff. And I would definitely recommend that you do that. Read a couple of questions, then go to the admin interface and then try out the stuff yourself. Try to figure out something you want, something you find interesting, that's easier to learn. So what is the where clause in an SQL query? This is actually where we can filter out. The data. And this is where we can decide which kind of result set we want to be returned. But before we can use that, now again, let us get some hands-on and actually let us try to write a where clause. First of all, we need to insert some data into this captain's table right here. So I'll go to SQL command. I could insert one row at a time, but I've prepared some rows right here. So captains right here. As you can see right here, the syntax is insert into, and then the name of the table right here, which is captains, and then we say which field we want to apply, name and age. We are not giving the ID because the ID, you remember that this was auto increment, that is a primary key, so it will be automatically filled out. So you should not mention the ID. Then I give it some values, Mike45 right here, and then you end your SQL with a semicolon like this. And I've done that a lot of times, as you can see right here. I just made up some names and some ages. But before we actually do that, let me just change the table. Let me just drop the experience field first. Also table captains, we regretted the experience column. We do not want to use that anyway, so I'll just say also table captains, drop the experience column. And now that column is gone. If I go look again at my captains table, I can see my definition has ID, name, and age, but now there's no experience column. It's easy to alter your tables, even though you created your table and you regret something that could come with time. It could also just be, of course, that you had a typo in one of the column names. You can just write alter and then change it. And again, if you don't know the syntax, you can press alter table right here. Then you can actually change whatever you want. So you can change the name and then you can press save, and then you will get the SQL as usual. But now we want to insert some data. So we will just go here and I'll say insert captains. I'll mark all of my SQL right here. I'll paste it in right here and I'll press execute. So now I got all of these. I got a lot of SQLs executed. Actually, every time there was a semicolon, then there was a new SQL being executed right. Let us try to go to the table captains, and then now let us see the content data. Here I can see now we have all of the data right here, and we can see this is the select statement as it's called. This is the SQL select statement right here. Select star from captain. Star means all columns. This is asterisk right here, that's a wildcard. Means give me all columns from the captain's table. Limit 50, that means give me only the first 50 rows. It's always a good idea to add limit to your select statements, because if you have a database with millions of rows, then you could actually, performance-wise, you will take all of the performance if you start selecting 2 million rows and you want all of those returned, even though that you actually just 10 rows just to see what kind of data that was actually inside the database. So always use limits. Especially to begin with, so you don't influence the performance of the database and make it run. So select from captains. Here we can have the where clause. Remember the question that we are at right now. What is where used for? Then we can say where age greater than 50. This is the how to filter out data right here. So here I say. I want all of my captains where the age is greater than 50. I don't care about the limit right now because I know that this data set is so small that we don't need to add that. I'll just say execute. And now I can see, now I only get all of my captains, Karen, Lisa, Niels, Torben, Jens, where the age is greater than 50. So we just filtered out them all. Of course, we can also say less than or equal to. Then I can press execute right here. Now I only get the people younger than 50 years old. So that is actually how easy it is to use the where clause. It is very strong, and that it is used a lot, especially for business reporting, for instance. It is actually used for every time you have a select, you should always have a where clause to build out and to give you exact the data that you need. Usually, if you see a select statement and there's no where clause, then it's because there's an error and you should not execute that SQL because it would actually it would be running for a long time because if you have a lot of rows inside that table, selects from. You should almost always have an where statement. So let's go back to the questions. What is a clause in SQL query? We can filter out the data. We can also group the data. We can also order the data. So now let us try to use the order. The order data. Admin right here. Right now they are not ordered by name. If I want to order them by name, let's write order by the name. You can also order them by age first. And let us start with age. So we have age right here. That is another clause. We have now order on, and then we can see that we're actually ordering, so we get the youngest captain first. And if I want the oldest captain first instead, then I just write disk for sending, execute, and now we get the oldest captain up. Another type is if you want to group and if you want to summarize stuff, then that is also called a clause. So filtering, selecting, grouping, and ordering, all of those are clauses in the SQL query. Grouping can be used if you want to count, for instance, if you have a crash log where you see all of the log dates for when a captain has crashed, and then you can actually then summarize these or count these by using functions. Those will be a part of the advanced question set, and it will not be shown in right here. Then we have the different types of clauses right here. We have select, that you have already seen. Then we have from, that this gives which table is it that we select from. Then we have where, which actually filters out data. Then we have order by, where we can order our data and sort our data by one fields like age or name. Then we have group by, where we can group up if we want to run functions on data, like summarizing stuff. Then we can use group by. And then we have something called having, that is also a clause. This is used to manipulate the data after it's fetched. So this is if you want to, that's a good example right here. For instance, if we group the data of employees by gender, then try to retrieve the number of male, female, and need the record with count more than 100, then this clause could be used. I would say that if you can, then use try to keep it. Use the where and the group by and then the functions. That's my recommendation because it performs very well. So then we have number 10 right here. Is it possible to select data from multiple tables at the same time? This is exactly the strength of a relational database. That is that you can actually have relations between the tables, and then you can actually join the tables. And you can also use something like subqueries. Then we can actually extract data from more than one table at a time. And we are going to see this in just a minute. But this is one of the big strengths of databases. We have different types of joins. So we have inner join, which will return the records that have values matching the columns in both tables. So that means that if I have one row with a relation to another table, and that other table actually does not have that row, then that row will actually not come out as in the result set because it's an inner join. Then we have a left outer join. The outer joins, both the left and the right outer joins, they actually mean that you will have data which is only present in one of the tables that you're trying to join. And the left outer join means that they will return all records from the left table, while only the match records from the table. And with the right outer join, it is the opposite, the other way around. I'll show an example of this, so it does not matter if it sounds a little bit confusing, but you need to know about these different types right here, and definitely play around with them inside the admin interface. Then we have full outer join. This will actually, then it would not matter if you have the data in just one of the tables, then you would get that data out. And in the beginning, it will probably be full outer joins that you want, so because you kind of want to see the relations like it was in a spreadsheet, especially in the beginning when you're trying to learn to understand what is this, what are these relational databases and what can they be used for. But now we have actually learned already a lot right now, so let us see some practical examples on these joins, because that is one of the most difficult part relational database, that is actually the joins between the tables. So I'll go to my admin interface right here, and I've prepared because right now we only have one table. We only have one table right now. That is the Galaxy. We have the Galaxy database, and then we only have one table, which is the captain's table right here. So we need another table so we can join these tables together. And the other table that I've prepared is the crashes table right here. So I want to create a new table. Again, all tables should always have an ID, so you can actually refer to and find a specific row there needs to be something unique by each row in your table. That is why it is good practice always to start your table definition ID, which is not null and which is the primary key. That will also auto increment automatically, so it's not something that you control. And of course, there should be no information inside the ID. It should be auto generated. Then we have the captain ID right here. So this is the relation to the captain table. This captain ID right here, see, it's not the name of the captain, it is a captain ID. This means this ID that we have here. We have captain's ID right here. It refers to the ID of the captain's table right there. This is called the relation. Then we have a number right here, number of crashes. This number of crashes is the number of crashes that the pilots, the captains, has done until now. And so that is the table we want to create. And copy. We go back and we say SQL command, and then we execute this part right here. So now I have a crashes table and I have a captains table. I have no data right now inside if I press select data, then there's no data right there. No rows, it says right here. So we need to insert some rows, and of course I've prepared some data that we can use. Insert crashes right here. I'll steal these 4 right here. And here you can actually see we have insert into crashes, and then we have captain ID, number of crashes. And as you can see right here, we only have data for some of the captains. If the captains has not crashed at all, then we have chosen not to have them in this table at all. And the reason for that is because then we can play around with left outer join and right outer join in just a minute. So now we have some data, and let us just see the data. Continue. So here we have captain ID 4, 3, 6, 10. The number of crashes 12, 2, 2, 2. That's good. Cool. Now let us try to create a cool query. I've already prepared something right here. So we have. I'll just copy this one right here. So we have select everything. This is a asterisk right here. This means select all the columns from captains from the captains table. And this is an alias. If I write cap like this if I write anything after the name of the table, then that is called the alias. That means that now I can refer to instead of writing captains, it can then I can save some typing by just writing cap. This. Then I say that I want to have a full join on crashes table. And again, now I'm creating an alias, so that means that instead of writing crashes in quotes, then I can just write crash like this. Then I say on, and then I need to mention the relational the columns where the relation actually exists on, and that means the captain ID like this. And that equals to crash.captain ID right here. And because we have full join, that means that we will actually get all of the data in both of the tables right here. And here we can actually see that we have some crashes for some of them, for some of the captains, but not all of the captains. Now we are, Karen, she went on, she was retired now, she's 88 years old. So I will actually delete her from the captain table, and the reason why I want to get it right there, because I want to show you that even though the data is not in the captain's table, then we will still get the row out resulting result set right there. There's multiple ways of doing that. The fastest way is actually to press captions right here. Then select data, and then I can say currencies right there. Or then I'll say delete. And it says, are you sure? Yes, I'm sure. Again, now we actually can see an example of delete. Delete from captains where ID for. And it is very important to have the where clause run right here, because if you do not have that, then I would just delete all of the captions. If you just execute delete from captions, then all of the captions will just be deleted, and yeah, you will have no data in your table afterwards. So I'll remember this where statement right here. But now Karen has been deleted, and means if I go back and execute the same SQL again, now we can actually see we have one ID here with null. There's one captain missing right here. That's because we have data in Crashes table, but there's no data in the captains. There was no ID that matched the captain ID 4. It's not there at all in the captains table. Then it will be shown like this. And the reason why we see this at all is because we have full join. We have full join right here. And also the other way around, Paula has never crashed, so there's no data in the crash table. That means that we will just see null values for all the data in the crash table like this. Now let us try to edit it a little bit. Instead of full join, that we will have left join, left outer join. This. See what happens now. So now we will only get rows returned where there are data inside the captains table. You can see right now there's no null data right here. The crashes for captain ID 4 is gone right now. That's because we have left outer join on crashes. This means we will start from the captains table, and we'll only join the data from the crashes table whenever we have data in this table. Of course, we can do it the other way around. We can say right outer join. Let us see. Maybe you can guess what actually will happen now. Now we only get the rows returned where there are data in the crashes table. So this means that now it's the crashes table where we start out from, and then it does not matter that there's no captain. We will still get this captain returned right here. So those are the difference. I hope that this made it a little bit more clear what is meant with these joins right here. This is how the database should actually join the tables when it needs to return. So we also have an exact join. There are multiple ways to do the exact join. One way is actually we can just mention crashes from the from part right here, and then we can say where. Then we can say captain ID to cap ID like this, and let us see what happens now. Now we only get the results, so we only get rows returned where there is data in both of the tables. This is called an exact join. We say that we have captain ID equals to crash captain ID here. Now we only get 3 rows returned because those are the only 3 captains that actually have crashes data on them. We also went through what are aliases in SQL. Select something, and then we can have a space, and then we can have an alias. You will see that a lot. I would say in the beginning, don't use aliases actually, because it will just make it more difficult for you to actually understand what is meant. But of course, it's up to you. You can see here it can look a little bit shorter, maybe especially if you are selecting from multiple tables where you have the same column names. Maybe you had users with name, email, and then maybe you also had something like administrators, an administrator table. also with a column named name, then you have to say which column it is actually is that you want to see. Is it the one from users table or is it the one from administrators table? And we saw that how do I join table using comma separated table names. We saw that in the last example, right? What is an inner join? Here we can see we have an inner join. Inner join is used to join records from two tables using a common data structure. For instance, in the data above where we have that, then you can write this in inner join right here. So that is the same as an exact join, and that is what when I told you that there are multiple ways of writing the same thing, then we could actually have written it. This is the exact join right here. Then we have the inner join that can be placed. We can create an inner join like this, and that will give us exactly the same result as an exact join. So exact join and inner join are usually give you the same result. Left outer join, yeah, we saw that with an example. Right outer join, we saw that with an example. Full join, we saw that with an example. How do I insert a record using SQL? We actually already saw that. Insert into table name, then values, and then we give the values for how to for whatever we want to insert to the database. How do I update a record using SQL? We have not seen that, so let us go back to the administration tool right here. Let us say that now we have our captains right here. I'll just select all of them. Mike, Jane, John. John, he just had his birthday, so he's not 33 years old anymore. He's actually 34 years old. Of course, we could write the SQL ourselves, but we are a bit lazy, so I'll just press right here and I'll say edit. Then I'll say now he had his birthday, so now he's 34 years old. Say save, and then we'll get the SQL command right here. Here I can see update the captain's table, set ID equal to 3, name equal to John, age equal to 34, where ID is this. There's an easier way to do that. And let me just show you that actually, because you do not need to mention the tables that are not being changed. So we could actually leave out these two right here. Of course, if I want to change the name John to something else, then I could write this other name right here. But right now we only wanted to change the age. That means you only need to mention that column that you actually wanted to change. Here again, it is very, very important with the where clause. If you do not have the where clause, then you would change the age to 35 for all of the captains. Of course, that is not what we want in this situation. Now let me press execute, and we can see that actually works out fine. And we can get all data from the captains, and now we can see that now John should be 35. Yeah, now he's down here. Still with an ID 3, of course. That is his unique. It's a unique way to find the row in the table. So that was how to update a record using the SQL. How to delete? We have tried that already. Delete from, and then we say where ID equal to something. Of course, we can also delete a bunch. If instead of using the ID, we could delete all of the captains with an age greater than 40, if that's what we want to. Order by, we have already used that also to sort the captains by age. Is it possible to order the records by 2 column? Did we see that? Let us just do that. So, SQL command right here. I'll just go captains, select, and then we just put it right here. Select star from captains, and then we say order by, and then we can say name first, and then we can say age afterwards. Actually, the other way around. First age and then name, and let us see what actually happens. So first we get them by age, and then we get them by name. So here we can see we have both Brit and Jane. They're both 35 years old, but because B becomes for J in the alphabet, then we will have Brit before Jane. And then we have John afterwards because JO becomes after the A in the alphabet. So that is how to sort. To order by multiple columns. Let me just say name disk. getting. Then we can see that now we got the other. First we get John, Jane, and then we get Brits all the way around. Pretty cool. Pretty cool. How do you check for records having no data for a particular column? Yeah, we have not seen that. We can actually see here, select star from table name where column is null. We have to use or join to get into that situation. So I'll just paste to go to my project right here, and let us say that we just copy this part right here, because in this full join we have a lot of null values, right? So let us say that we do not want anywhere the name is null. Then we can easily do that by changing where name is not null. So now we will not get any rows where the name was actually null. Those will be filtered out. And that's actually the basic. Those are the basic questions. I definitely recommend you to read up on the advanced questions also, because here you'll learn about functions, also how to use the group by and like, etc., etc. It is a little bit more complex, but it's always good to try and execute these SQLs in the admin interface. This is it's a quite good article. I hope you liked this video. If you did, then please like, subscribe, and hit that notification bell, because we have a lot of cool stuff coming up. Bye!